Hey everyone, today we'll be going over how to detect a linked list cycle. So there are three big ideas that I want us to focus on. First, in a singly linked list, there is only one direction to traverse the list, and that's forward. Secondly, how do we determine when a linked list ends? And finally, can we control the speed at which we traverse a linked list? So this is a quick refresher of what a linked list looks like. As you can see, it's a singly linked list, which means that I can only move from node 1 to node 2, and I can't move backwards from node 2 to node 1. And this is what the code looks like. When we initialize a node, we have a value, and we have a next. So the value is represented by this number inside the circle, and then the next is the arrow pointing to the next node. So in a typical singly linked list, there aren't any cycles. And the way we know this is because the last node just points to none, as opposed to pointing to a previous node. However, if there is a cycle, what does this look like? We see that node 4 would point to node 2, and what's going on here is we're just setting the next value of node 4 to node 2. This is the crux of how we're going to solve this problem. There's going to be two pointers, slow and fast. Slow is going to move one node per step, and fast is going to move two nodes per step. What does this look like? So slow and fast both start at node 1 initially. Then slow advances one node, and fast advances two nodes. On the next iteration, slow moves to node 3, and fast will take two steps, so it goes from 3 to 4, and then 4 back to 2. Now, this is how we know that there's a cycle, because slow and fast have gotten to the same point. How does this work? Let's take a very practical example, and say you and your friend are going to go for a run, and you meet at the track. Now, you're going to be the one actually only running, and your friend's going to take it easy and just walk, right? And because this track is an oval, or a circle, wouldn't you eventually catch up to your friend? And this is the same idea here. One pointer moves faster than the other, so they'll eventually catch up to each other. So each iteration, the faster pointer is closing the distance by one node. This is what the code looks like. So the function takes in the head of our linked list, and we initially want slow and fast both to be pointing to the head. Now, while slow and fast.next, this line is basically checking that we are in a loop, because if slow doesn't exist or fast.next doesn't exist, then we know that we've exited the linked list and we can just return false at the end. This is the part where the slow moves one pointer at a time and fast moves two nodes at a time. Now, if slow and fast equal each other, that means we are in a cycle and we can return true. Otherwise, that means we've exited our linked list and we can return false. Thanks for watching, and let me know if you have any questions or comments below.